Hey everyone, Jerry here from LlamaIndex. Today, we're excited to host another edition of the LlamaIndex webinar series. And the topic of today's webinar is best practice data preparation for RAG. And so I'm personally super interested in this topic because we've been talking a lot about the importance of the data processing layer in building any sort of like question answering knowledge assistance system. This consists of like parsing, transformations, like chunking, metadata, and also indexing. And so today we're excited to co-host a workshop with the co-founders of Deasie, with Reece, Leonard, on improving RAG systems. And I think it's actually, I took a look at the slides and the experiments. We show you step-by-step on how parsing and especially the metadata extraction piece can directly lead to performance improvements. So it's a very practical and technical workshop. And hopefully, we all leave here with some really interesting learnings. So as always, drop your stuff, drop your questions in the chat, and we'll try our best to answer it either throughout or towards the end. All right, passing it over to you.
Thanks, Jerry. Firstly, hey everyone, really excited to see so many people here and very excited to talk you guys through this. So maybe just by way of quick introduction, and we'll kind of go through this more as we continue. So my name is Reece. I'm one of the founders and CEO of Deasie. Along with Leo and Mikko, our the co-founder, we lead basically a data labeling company. So our core focus is providing kind of a best-in-class workflow for generating high quality, standardized, hierarchical metadata. We work with typically larger enterprises on data transformation and kind of data readiness for AI. And one of the core use cases, kind of as Jerry alluded to, is using and embedding metadata into kind of RAG workflows. So, often the situation is, a POC or as kind of a test RAG pipeline works quite well on a small number of documents, but either as that volume grows or documents become more complex, maintaining accuracy and scalability is hard. And so metadata, as we see, is one of the key tenets to ensuring you can actually deploy RAG tools in production. We're big fans and users of LlamaIndex, so have been admiring Jerry and team for some time. So excited to kind of collaborate on two of the key sort of tenets as we see of data preparation, parsing and metadata. So, and as Jerry mentioned, so Leo, our CTO and one of my co-founders is here to answer any questions. So feel free just to ping things in the chat. So in the session, there's quite a lot of info here, so we'll go reasonably swiftly through. We'll talk, kind of give a brief overview of both LlamaParse for parsing and Deasie for metadata creation. We'll talk a little bit around like the role of metadata in RAG and a few different ways sort of high quality tags can be used to improve retrieval. And then we'll go into an experimental setup and talk about some kind of concrete results where we used a large volume of research papers, asked a few different questions and showed kind of how the parsing and metadata has a significant impact on performance. So, I'm sure many people here are familiar with kind of common problems of RAG by now, but especially once we start to get in the domain of complex documents. So, as we're seeing here, research papers, which is the kind of core focus of this discussion, having these kind of multi-column structures, embedded charts, tables, and so on. And four of the common problems that we see is LLMs selecting the wrong document or the wrong chunk of document when a given question is asked, the inability to pull from charts, graphics, tables, complex formatting as shown, which basically means important links between data and different sections of the data are lost. And then the fourth piece here is that latency, cost, and also accuracy typically become problematic as data volume scales, especially beyond kind of hundreds and thousands of documents. So two of the key areas that we see data teams, data science teams investing in from a data preparation perspective that have the biggest impact are parsing and metadata. So on the parsing side, good high quality parsing means that you can, one, extract information contained within tables, charts, images, and secondly, and this is kind of more the focus of this discussion, maintain important links between different document sections. And metadata, as well as improving and maintaining those links, also allows models to pull from the most relevant chunk or relevant document. And finally, enable very quick filtering of documents or chunks as the RAG scales to large data sets. So the workflow that we will kind of talk through as a basis for this discussion is the following. So taking a large volume of research papers, using LlamaParse, which Jerry will talk through in a moment, just around kind of best practice parsing. We're then using page-based chunking as a kind of baseline throughout, using Deasie's metadata creation, which we'll talk about in detail, embedding that or bringing that metadata into an index using Quadrant for our vector DB. And then we're going to look at two approaches to leveraging that metadata to improving RAG. So one is filtering the embedding space based on some metadata attributes. And secondly is using a router query engine to effectively use an LLM to then assess document level metadata and make an assessment as to, for this question, which is the best document for to retrieve the answer from. So Jerry, I don't know if you want to just give a quick overview of LlamaParse for anyone not familiar, and then I can do the same on the Deasie side.
Yeah, for sure. Yeah, no, thanks, Reece. So the one of the product offerings that we have is LlamaParse. And so, as you know, LlamaIndex is the open source package, and LlamaParse is part of the Llama Cloud offering, our managed service for helping users process and centralize unstructured data. So LlamaParse specifically is a very good document parser for complex documents. What is a complex document? It could include, the picture shown in the slide. It could include like a financial report, insurance document, medical record, anything with a lot of text, tables, charts, diagrams. So really like multimodal elements within the document, maybe with interesting spatial layouts, and oftentimes for human consumption rather than just for like API-based extraction or consumption, right? And so our goal is to really parse and format the text in a way such that LLMs can understand it. It's powered by GenAI LLM models, and it's designed specifically for a lot of these LLM use cases. So some of the core capabilities that's pretty good at, it can parse like PDFs, PowerPoints, DocX files, HTML. It can extract out images and charts and diagrams from the image or from the document. It's good at parsing tables into a markdown format or just in a nicely like spatially laid out grid. And you can also actually put in like input prompts so you can parse it in the way that you want it. So, it's one of the first stages in this data processing layer, and it's a standalone API. And it's one of the components of this workshop.
Awesome. Cool. And then on the Deasie side, so as mentioned, our core focus is all around creating metadata. And we'll talk about kind of the different attributes of that. Just, I guess, a bit of background on the company, as I mentioned. So, we work typically with data and data science teams and enterprises on labeling and metadata creation across large volumes of unstructured data. This could range from improving RAG accuracy and scalability to kind of broader data cataloging to some elements of data quality, finding and removing, outdated versions of documents and sensitive data. And like parsing, we see the metadata and labeling piece as a critical component to a best-in-class data preparation workflow. We have kind of a UI-driven platform. We also provide these labeling services via an API. I think Leo and Mikko will share in the chat. We're just opening up now a waitlist for kind of more broader public access to our tagging services via an API. So if you're interested as we go through the session in exploring kind of best-in-class metadata creation, definitely fill that out and we can be in touch. And yeah, a background on the company. So we spent a number of years kind of building and deploying sort of machine learning data quality and data governance products at McKinsey with a lot of Fortune 500 companies, and kind of saw unstructured data labeling as a real gap, especially doing so in an automated way. So when we talk about metadata, some of the key tenets here are making sure this metadata is fully customizable, auto-suggesting the metadata, so actually taking a corpus of information and suggesting what is the relevant set of tags for this data instead of putting that burden on the user, making sure that metadata is standardized, ensuring that metadata is hierarchical as well, which can significantly improve the efficiency of filtering within, for example, a vector DB and capture important connections between document sets. Ensuring the metadata can be scored and has kind of associated quality and is verifiable, can be traced back to why did the model actually extract this value for this particular tag. We ensure that metadata is captured both on a chunk level and a document level, and the chunk level metadata is intelligently synthesized to a document level tag, depending on the type of tag. All the metadata, so we're largely powering this through different LLMs and focused on using kind of in-context fine-tuning and few-shot learning to improve label accuracy via some human-in-the-loop workflows. And of course, making sure that you can do this at scale across large volumes of data. We'll kind of jump very briefly to the platform later on, but effectively the very simple flow is connecting to data here, chunking the documents, either then defining tags or having the model suggest tags, validating the accuracy of those tags to then improve the quality via this human-in-the-loop workflow, defining or generating relationships between the tags, and then exporting both the labels plus the hierarchies into, let's say, a vector DB for kind of downstream consumption and use in RAG pipeline. We're going to give a quick overview on the kind of role of metadata in RAG, just because some people may not be kind of yet familiar with the importance of this. Maybe up front, when we talk about metadata, I think people have different associations with that word. We're talking basically around, distilling data down into categories of information that basically represent large volumes of data or information with more succinct information. Of course, depending on the type of document, and we're talking about unstructured data here, this could be anything from, legal documents and calling out the presence of certain clauses to versioning tags to kind of more semantic, descriptive tags in the patient record, what were the particular side effects of a given drug and so on. And this metadata could be open-ended. It could be metadata that is mapped to a set of hierarchies or defined values. They could be yes/no metadata. So really, we're talking about a very broad set of tags for this use case. Now, in terms of where does this play a role in building sort of RAG pipelines or Gen AI more broadly, we see four core areas. So prior to any question being asked, using metadata to, for example, identify the latest version of a document, filter out sensitive information, and effectively sort of pre-filter data ahead of LLM usage. Secondly is using metadata to create more intelligent segregations of documents within a vector space. So for example, creating a cluster of documents for each policy type, each patient, and so on, so that you can have more efficient routing downstream. But the focus of this discussion is on how do we actually, once somebody asks a question, how do we use metadata to intelligently find the relevant document? And here there's two approaches. One is using metadata within the vector DB itself to basically filter down the embeddings. And this is kind of, I think, Jerry, you guys have the kind of auto-index, vector auto-index retriever, which is effectively using that metadata to filter the embeddings. And this is typically kind of more like a smaller number of tags which have narrowly defined values that do a good job of quickly filtering down large volumes of data. Then the second area is improving the routing accuracy, which is then actually adding metadata on top of each document. And this can typically be more semantic descriptive metadata, so that when a question is asked, the LLM can actually evaluate that metadata and then make a decision as to whether it should go into that document or not. And this could be at a document level, but this could also be kind of, more of a, I guess, agentic framework where this is like different clusters of documents. And above each cluster, there is some descriptive metadata. And then an LLM can first assess that metadata to decide if it's worth kind of going into that document set or that document. I mean, to put it in very kind of simple terms, no metadata means question comes in and an LLM is going to potentially have to look at every chunk of information or every document and then make a judgment call on is this kind of relevant for this question. And this is where you fall into kind of these issues of potentially choosing an erroneous chunk or an erroneous document for a given question. Now, with the metadata scenario, if we first look at the filtering of the embeddings, this is basically creating metadata, which could be at the chunk level or document level, adding that into the vector store. And so when a question comes in, the first thing that happens is there is some pre-filtering step where this embedding space can be filtered based on these metadata attributes. As mentioned, and in the kind of in the webinar itself, we were using a sort of vector auto-index retriever from LlamaIndex for this. And as mentioned, this metadata here, typically best practices, this is kind of a small number of tags with sort of very strictly defined output values, so not open-ended metadata, which allows you to quickly segment data based on a question. So in this case, it could be policy type, it could be, some high level kind of, if you think about the high level tree of identifying relevant data, what are some of those top branches that would allow you to quickly filter and ideally discard, let's say, a third of the data that wouldn't be relevant for this question. Now, the second area is, okay, once we filter the embedding space, having metadata attached on top of each document, or this again could be a cluster of documents, which typically is now much more descriptive and semantic in nature, and allowing the LLM to first basically look at that metadata and make a decision as to whether it should pull from that document. And this is kind of, I think in LlamaIndex, again, this is the routed query engine. So again, in the experiments, what we will basically show is how we generated metadata and used it within LlamaIndex's routed query engine to improve this routing efficiency. And of course, the two benefits of doing this, one is scalability, in that an LLM therefore can make a much faster decision as to whether this document is relevant without actually having to look at the underlying information within the document. And secondly, have a much more higher chance of pulling from the right data. The other advantage is you can also capture some relevant metadata on each document, which could actually have the answer, which could actually contain the answer to the question. So if there are questions that are commonly being asked in a RAG pipeline, it can be worth embedding that metadata and attaching on top of each document so that can be the place from which the LLM pulls the answer instead of having to go into the document itself. So in this case, LLM effectively assesses the metadata on top of each document, makes a decision as to, okay, this is the most relevant document based on the metadata, and then can pull the answer either from the kind of document itself or actually from the metadata. And just a very high level, basically what we're saying here is, metadata in the RAG flow can allow you to rapidly filter down large document sets if that metadata has been intelligently defined and is standardized. Metadata can actually have a negative impact if it's not defined and embedded correctly. So for the discussion and for the kind of experiments that we'll show, we were looking at bringing this back to kind of the parsing plus metadata. Really kind of three scenarios that we were assessing here. So one is basic parsing using PyPDF and no metadata. We then looked at using LlamaParse for the parsing, again with no metadata. And the final scenario was using LlamaParse for the parsing plus Deasie's metadata, which was then embedded into or rather included within the RAG workflow using LlamaIndex's routed query engine. And needless to say, the kind of third approach here resulted in most accurate retrieval, which we'll show you. The data set we used were research papers, so scientific research papers, pretty complex in format, and lots of I guess relatively domain-specific information. We had around 100 papers here and asked around 100 questions across those papers, again using Quadrant as the vector DB. So firstly, we'll look at a couple of examples where using LlamaParse enabled a correct answer to be derived, whereas when we used the simple text splitting and transformation with PyPDF, the LLM pulled the wrong answer. So basically, the comparison here is no metadata, but comparing LlamaParse with PyPDF. And we'll show you two examples. So Jerry, I'll give a quick overview, and then I'll let you build on anything here. So ultimately what we're showing is this first example is a very common case of the answer to a given question is actually split across, in this case, multiple pages. Right, so the question in this case comes in, which is what percentage of newly diagnosed patients with leukemia are cured using ATRA therapy? And if you actually look at the text here, you see this information is split across these two pages. So currently about 90% of diagnosed patients with acute leukemia on this piece of text, and then achieve complete remission, and over 70% are cured with ATRA. So needless to say, like the LLM is going to need to, these two pieces of text are going to have to be connected in some way in order to derive the answer. With PyPDF, the answer was that 90% of patients are treated in this way, which is obviously incorrect. Whereas with LlamaParse, these two sections were connected, and thus the right answer was able to be derived. Jerry, I don't know if you'd build on that in any way.
Yeah, no, I mean, this is a cool example. And to be totally honest, I'm actually not entirely sure why LlamaParse does better in this case. I think because it might be dependent on how you're like joining text across pages. Typically where we see like LlamaParse having like the advantage, to be clear, is like where, for instance, like the text is laid out within a page in like a very spatially weird way. And so like PyPDF will like collapse the table values, or will like collapse the text, and then the LLM gets really confused because the text is like all jumbled spatially. Whereas LlamaParse has like, markdown formatting for the tables. It can like lay out the text in like a nice grid. And with parsing instructions, you can also attach annotations onto all the text, so it has context. That's where we typically see some of the improvements here. But yeah, no, it's a cool result.
And maybe the second is more tied to what you'd expect than Joe.
Yeah. Yeah, I think this part makes sense. Like the 2-column layout within a single page, and then like, you're able to join text across like the 2 different columns.
Yeah, exactly. I mean, this example here, very simply, same thing. What type of cancer is inhibited in rats when treated with sarcopamine? And if you actually read the text here, you need both of these. The answer is effectively in the top right hand side column. And so without LlamaParse, we're pulling the wrong answer, but with LlamaParse, the link between these 2 sections is maintained.
Yeah, this part makes sense.
Cool. Awesome. So then we'll look at the role of metadata in kind of the RAG accuracy results as well. So here, effectively, as mentioned, we're comparing the 2 scenarios we're effectively comparing and now we're using LlamaParse in both cases. The first is without any metadata. The second is then the bottom workflow here, creating metadata, adding that into the vector index, the VexDB, and then using both the kind of vector auto index retriever and the router query engine to leverage that metadata for RAG. And just as a reminder, as I said earlier, there's 2 ways to use metadata here. First is filtering the embeddings, for which you could use LlamaIndex's vector auto index retriever. And the second is then actually routing the LLM towards the most relevant document after the filtering has happened. And for this, you could use what we used for the testing was the router query engine provided by LlamaIndex. And this was primarily the second one here is primarily where the focus of our experiment was, i.e., adding metadata on top of each document and using the router query engine to assess that. So one important thing here is, as I mentioned, the metadata that we're creating in Deasie is kind of chunk and document level. So as data comes into Deasie, we're chunking the document up. We're then defining metadata. And so this metadata can either be auto-suggested, and we auto-suggest basically the best metadata for RAG by looking at the information contained within a large corpus of documents and suggesting what is the relevant metadata for retrieval based on the information in these documents. Or a user can also define this metadata. The metadata is first extracted at the chunk level, and then we have a synthesizer layer to effectively roll that up to a document level tag. And this takes into account, the type of tag, the type of metadata. So the resolution to a document level tag is intelligent and makes sense for that tag. And then that metadata can be exported out of the platform along with any hierarchies that are defined. Importantly, at least in this setup, the way we use the kind of chunk versus document level metadata is chunk level metadata was included within the vector DB. So this kind of filtering of embeddings actually used chunk level metadata, whereas document level metadata was used on top of each document for within the router query engine. In terms of like what metadata was generated here, so we kind of I guess within the context of RAG, distinguish between 2 types of metadata attributes. One is kind of custom metadata tags, and these are tags which effectively are very specific to the document set of interest. In this case, these were scientific research papers, so this included things like the research domain, research subdomain, the publishing date, the name of the publisher, and some other areas. There are then some generic tags, things like the purpose of the document and the key questions the document is well placed to answer. So the metadata we use includes both these custom tags as well as these generic tags. And before I just jump into the results, I will just quickly show you guys the platform just to kind of show you what this looks like in practice here. So these are the research papers in here. So you're looking here at the kind of data catalog with all of these are research papers on the left-hand side. And then the tags in the middle are effectively the metadata that was extracted. So you can see in bold the name of the metadata, and then the non-bold text is the value that metadata took. For example, subdomain, battery electric vehicles. So this is kind of what the sort of tagged catalog looks like. And if you actually open any one of these, you'll see the metadata plus associated evidence and so on, as well as what metadata was at the chunk level, what was at the document level. And the process of creating metadata within Deasie, as I mentioned, is there's two ways. So firstly, we can define a tag manually. So this basically, in this case, very simple, are the author's emails included? And this is a yes/no tag. And you basically, provide a description, constrain the output values if required. There's then kind of validation and quality scores that are generated in the platform and updated. And then we have kind of labeled input-output examples, which are used to effectively in-context fine-tune the labeling model. And this is all produced via kind of a human-in-the-loop validation workflow once you create and test these tags. The second area, though, is auto-generated tags. And this is basically where we dump in a large volume of data sets that we're going to be running a RAG pipeline on. And then Deasie will effectively assess the information within there and suggest relevant tags that can be used for filtering in the context of RAG. So, for example, it suggests a tag called agricultural practice, which is the type of agricultural practice being analyzed, and then lists out the kind of relevant categories based on the data. Another one might be, product type, the type of product being analyzed or compared within the data. So these are auto-suggested tags. They could also be open-ended tags, things like, for example, does it talk about sustainability strategy within this document, or what sustainability strategy is discussed, what effects of climate change are discussed, and so on. So that's just a very quick kind of high-level view of how the sort of platform works in terms of defining and auto-suggesting metadata.
So would you recommend the user flow being like, define some human annotations first and then try auto extraction, or how would you typically encourage users to go about this?
In most cases, it depends how. So the auto generation works best, obviously, when the documents are somewhat similar in nature. So what we often find is like what can be very powerful is you first define a tag, for example, like document type, let's say, that is going to allow you to quickly segregate the data. And these tags, if you link it back to the discussion, maybe the filtering embeddings tags sometimes are best defined by the user because they understand how could I quickly cut down this set of documents into smaller subsets. And then the more kind of semantic metadata that was, for example, used in the router query engine, we typically find it's best to run the auto suggestion first, and then users can take those tags, edit them, adjust them. But that's generally what we see, especially as data volumes get very high. So one of our customers right now, they're kind of doing an A/B test on 4,000 documents, and it was just much easier to auto suggest and generate the metadata. And then they kind of selected the most relevant tags and appended a few of their own. I don't know, Leo, Mikko, if you guys would build on that, or Jerry, yeah.
So you're basically like, in my mind, it's metadata extraction with like two steps, right? The first is like defining the schema, and the second is like extraction into the schema. And so for the first step, you're saying you might have like the human like define some of those like tags, like keys basically, or you have some auto suggestion in terms of the tag keys, and then you extract into those tags. Am I thinking about that correctly?
So yeah, there is also like another flow around like when you use the platform overall, we can validate which tags have been used and how does a good tag actually for a user, for every specific user actually look like, which will then be basically reinforcing the generation of the tags themselves.
Yeah.
Okay.
Yeah, but that's exactly right. The schema can be either user defined or also auto suggested. So like in the example we just looked at, the model suggests both the tag name, but also the possible set of output values. And then the extraction step is simply mapping every document to one of those. So yeah, there's kind of two ways of doing that.
Got it.
Yeah.
Cool.
And then I think a lot of the challenges that we see come in around like the metadata isn't standardized. The metadata doesn't reflect kind of important relationships between tags. Hierarchies are important. So it's like if label X, if tag X has this value, then I should run these subsequent tags. And so having kind of a way to build in that slightly more nuanced sort of approach to defining metadata is quite key in the RAG setting. I'll blast through in the last couple of minutes on the results here, and then we'll open up to any questions. So just showing on the screen, some of the example questions we ran in the RAG. So for example, what are the advantages of using silicon nanopillar anodes over traditional bulk silicon anodes? What are the processing techniques and parameters for manufacturing weak gluten-based bioplastics, and so on. As mentioned, we used LlamaIndex's router query engine to effectively route the queries based on the metadata. And so here are the results on the metadata side. So basically what you're looking at here is, as we increase the number of documents in the document set, how did the retrieval accuracy change? And we defined retrieval accuracy as, did the model pull the correct, the most relevant chunk or the most relevant document actually for the given question? And I guess a couple of observations. One is, as you'd expect, the impact of metadata is that the accuracy can be is significantly higher, so closer to sort of 95%, even when the document set scales. So metadata allows the accuracy to be maintained at higher levels of data. And secondly, the impact of metadata is more, I guess, more pronounced at higher data volumes. So as document sets are very small, metadata does have less of an impact. And this is often what we see with data science teams, in that, POC RAG workflows are often starting out with a very small number of documents, hence why kind of the role of metadata doesn't seem as relevant. But certainly as volumes scale, we see it being very critical for both improving and maintaining accuracy. The second thing we looked at is kind of what type of metadata had the biggest impact. So as mentioned, we had kind of generic metadata around things like document purpose and key questions. We then had much more specific metadata to this use case, things like scientific research domain, publication date, publishing institution, summary of the future research proposed, and so on. And these tags were both user-defined, but also some were auto-suggested. Jerry, to your point, so this was like a hybrid kind of user flow here to come up with the relevant set. Overall, I think there was around 20 tags that we used. And the result here is basically, if we compare the green case, which is using all the metadata, the kind of key takeaway is that when we only use the custom domain-specific metadata, the accuracy, the retrieval accuracy was basically maintained. So the uplift in accuracy, or the uplift in retrieval accuracy from metadata, at least in this experiment, can pretty much all be attributed to the custom sort of domain-specific metadata. Whereas when we just had, in this case, the kind of key questions and summary semantic metadata, we actually didn't see much improvement at all. So this is, if you can look at the orange and the blue lines here, this is basically comparing no metadata in blue with kind of generic metadata, again, which is just like document summary and key questions.
Yeah.
Leo, and is this custom metadata? Is this like a combination of like auto-suggested and human?
Exactly, yeah. So this set of tags, I mean, this is just some examples. Some of these we defined, some of them were defined by that auto-suggestion workflow. Exactly. Because the auto-suggestion workflow is based on looking at like a corpus of information, the information like and kind of not back calculating, but trying to understand what sort of queries could be relevant for different documents, and then using some intelligent sort of mechanism to convert that into metadata. Leo, I don't know if you'd add on anything here. Otherwise, I think we can spend 5-10 minutes on any questions.
Yeah, maybe what I want to say here is that, like, in general, like all metadata, even across like different data sets, like very different data sets, like healthcare, for example, always outperform the best. However, like, for example, the performance between having, for example, only key questions or only the purpose of a document or the summary of a document for very generic documents can also improve the retrieval by a lot.
Yeah, that's a good point. Like this result is not like consistent with what we've seen in the past. Sometimes using just key questions or summary or purpose can actually add quite a significant uplift. But I think in this case, because the document set was quite complex, both in terms of the structure of the documents, but also the content. We found that the domain content-specific metadata was obviously far more sort of valuable. So I think that sort of wraps up a little bit what we wanted to cover. As mentioned, from the Deasie side at least, we're opening now access to, or at least a waiting list for first access to kind of a more publicly available API. Traditionally, we've only been kind of providing this to large enterprises, and now we're exploring kind of a slightly wider developer offering. And obviously happy to chat in more detail to anyone for whom this kind of topic is of interest. So do fill out that survey. I think, Leo, maybe you guys can just add that into the chat again if you're interested in chatting more on this. But otherwise, yeah, maybe we can stop here and open up for any questions in the last 5-10 minutes, unless, Jerry, you have any sort of closing comments at this stage or anything you want to mention on the LlamaParse side.
No, I mean, I think, yeah, this is a good presentation. Thanks for sharing. One of the questions from the audience is, as you think about like benchmarking different types of techniques, one is of course like using the kind of like metadata for like filtering, and then also for routing. One of the questions is basically what if you just like it comes down to a flavor. What if you just do RAG with re-ranking? So you just do like a big semantic search and you try re-ranking. And you don't include metadata. Like, what if you just basically set the top K to something very high, and then you just try to re-rank down and filter the results, if that makes sense, and to try to like get the relevant results that you want. Like, do you, for instance, like notice that including metadata allows you to more precisely filter for relevant results much quicker versus just like, you know, doing just a giant semantic search and then trying to like re-rank it down?
Yeah, so basically, like the connection between the metadata and the question is like easier to basically connect because you have different like metadata types. So for example, when you ask a question and you purely do it based on re-ranking and search, like you might not actually capture the nuances, especially if all of the data sets you're running it on tend to be very similar. And the second piece is like, obviously, if you have 50 documents, for example, this definitely will work with a re-ranking. However, if you go to like 1,000 documents or more, then the metadata basically becomes more of a question of cost and latency as well. Whereas if you like do like search now across all of the documents, you will run into the issue of cost. Yeah.
One of the like, I think 2 other people asked this type of question, but basically like if you have a large document corpus, some of which have like different or of different types. So maybe you have like a bunch of legal documents, engineering documents, like medical documents. Do you typically feel like a single schema for each across like all these documents, or would you actually recommend like dividing them into separate groups and then like, you know, doing separate extraction for each?
Yeah.
Reece, yeah, no, I think I mean, this is a great point. And I think this is where we really see like these hierarchies come into play. So the approach here is basically defining within the platform, for example, I mean, this could be document type, right? So tag is document type. And then if document type is legal, then we want to run, let's say, this tag. Whereas if document type is something else, then we will run, let's see. These are very random tags that don't make sense for this use case. But the idea is that the best way we've seen for dealing with like corpuses of information with a lot of variation is upfront defining what would be the tags to intelligently separate this out. Like document type would be an obvious one. And then defining, here are my 5 types of document. And then what you can do within the platform is you would first run document type. And then you can, based on that output, you can then create different clusters. So then I create my legal document cluster, maybe it's invoices cluster. Then within each cluster, we would then move into the auto-generate tag workflow. So that would basically be the sequence, which would be first define a tag to split out the data, and then within each cluster, then use the auto-generation workflow. And then the generalized way of mapping to that is that then all gets codified within one of these hierarchies, so that whenever you then add a document into the RAG workflow, there is then this sequence of first assessing some metadata, and then if it takes this value, then we'll run these tags, and then if one of those tags takes certain value, run certain tags below that. I don't know if yeah.
Oh, sorry, I was just gonna ask a follow-up question. So if you do this, if you do some sort of like metadata like hierarchy, which is cool, I mean, it makes sense. How do you actually factor that into, like, how do you include that into like a RAG pipeline? Because like different subgroups of the documents will have like different metadata keys actually.
Yeah, so basically, like, let's say if you have so what you can build, this is quite custom, but what you can essentially build is when you, for example, have the embeddings as part of the vector DB, right? And you have that object which showcases those relationships, then you basically like filter the data multiple times by that hierarchy. So for example, what we have said in the beginning is that especially when you filter embeddings, it's important to not have like 10 different metadata tags to potentially filter it, because it might be quite inaccurate. So what you do is that you start with a parent metadata tag to first filter it, and you essentially do that until you like get to a threshold which you're happy with. And by that, the LLM doesn't have to choose like between 20 different tags, but first chooses like the parent and then basically goes down the tree.
So do you launch multiple retrieval calls to the vector DB, or are you saying that LLM
Yes.
just traverses this metadata hierarchy first and then
It's the former.
does a final vector DB query at the end? Okay.
Yeah.
Interesting. Well, I wonder if like you could make this more efficient by having like a native operator with the vector database. So then you don't have to like insert a bunch of calls on the client side.
Yeah, no, that 100%. I think like for us, right, like there is also a lot around giving the freedom to our users, like on the rack side still, like right now, because people kind of want to use it in different ways. And we haven't basically been like, okay, this is how you have to do it right now. But yeah, that's definitely a good advice.
One of the questions is, are you supporting like custom models for, like I think the example here was like healthcare, but just being able to support like custom extraction models?
Yeah, I think the answer I put, so right now the labeling, the way we've built it, just because our customers often have preference for using certain models, is that it's completely agnostic of LLM. So you can, if there is a specific model that you want to use classification tasks, you can connect to that model and then still basically leverage the rest of the workflow. We are now also moving towards supporting like non-LLM based types of classification as well, because I think sometimes simple like NER, for example, could suffice instead of using LLMs. So yeah, the labeling itself is agnostic of the underlying model.
Great. Just going through some maybe one or two more questions before we conclude. Does having metadata in RAG help with like summarizing the content of each document? Or if you ask a question like key concepts within, what are like key concepts within these key documents? Does it help with those types of questions?
I mean, we haven't had much like summary use cases yet, so we don't have like experiments or anything on that. But I can imagine like if you can essentially classify kind of high level themes, it can help. But yeah, on our end, like summary use cases, we haven't really done much.
The one we have looked at though is like answering aggregate questions. So one of the areas that RAG often breaks down for people is if you ask questions like, how many investments have we made in the last 5 years where in this domain, with a company of more than X in revenue, that requires some form of like counting or aggregation across data sets. And like RAG typically won't do a good job on that. So what we do there is we extract metadata that basically forms the basis for the counting. So for example, one of our customers have thousands of wills, and they want to ask questions like how many of these wills, what percentage of this population of wills are complex, and complex for them they define as things like, are there multiple properties, what is the total value of assets owned, and so on. And so first that metadata is extracted, and then Leo, I don't know if you want to talk to I know we explored a few different ways of then basically having effectively an aggregation sort of layer on top of that metadata.
Yeah, I mean, in general, we have like something similar to like a synthesizer.
Yeah.
But LlamaIndex also, like, for example, something similar to that is like a list query engine, for example, which we then can use like to aggregate those.
Yeah, I mean, you implement like the auto retrieval piece, or in general, it's basically like launching a SQL query with like a where clause, right? So basically, if you wanted to really filter for the cell relevant documents, not by semantic search, but by like a specific tag, then you just like select set of documents through some sort of like structured query, and then you get back the result. And then actually, yeah, and then the last question, which kind of for me, is have you thought about like workflows where, you know, throughout the course of like the user querying the data, you actually like generate new metadata. So the data itself is not like static, but actually like updates or changes over time.
New metadata as in like you have a tag, like a label defined, and then you tag it, kind of?
It's a bit of like a vague idea on my end, but it's almost like if you have, let's say you have existing data and it's like unstructured, but with like metadata tags on top of it, and then the user is like querying this data, and then like some process, maybe it's automated, maybe it's actually like the user generates this. You like allow for a process to add more annotations to the document over time throughout the course of the user querying it, because that might help you get like even better retrieval accuracy, or even like human feedback almost, so that you're able to get back like more relevant results in the future.
Yeah, so I mean, in general, right, like users, for example, like validate values on the platform itself, which then also like feeds back into the kind of the labeler. But yeah, in terms of like generating metadata, what we have, so for example, is like the users can rerun the tags and they know when they have been edited. But like net new, or like kind of if you have tagged already on like 100 documents, we don't generate kind of like now you know, spontaneously like new tags out from the user interaction itself. But that would be, yeah, it's definitely an interesting thought.
Yeah, anyways, it's not super well fleshed out in my head. It was just a thought from like the user interaction patterns. Okay, great. Well, I think that's a good place to wrap up this webinar. Thanks so much for the great presentation. You know, I think metadata in general is a pretty underexplored like field that's pretty important for a lot of like retrieval, RAG, and also just LLM use cases. So thanks for kind of like shedding some light on that. All right, great. For everyone in the audience, we'll have the recording up soon, and we'll see you guys next time. Thank you.
Thanks so much.
Reece and Leonard.
Thanks, everyone.
Bye.
Appreciate
Bye.
that. Cheers, Jerry. Bye.